Okay, let's jump right in. We talk a lot about, compatibility in our jobs, our friendships, our relationships.
Sure.
But today, we're taking that whole idea and applying it to this amazing jet-setting seabird.
We are. We're diving into the world of the common tern to figure out what exactly they're looking for in a partner.
And it's a specific kind of looking, right? You called it assortative mating.
That's the term, yeah. If you're not familiar with it, it's basically the idea that animals, and us too, we often pick partners who are phenotypically similar to us.
So similar in ways you can actually see or measure.
Exactly. They aren't just pairing up randomly. There's an active choice for
Well,
similarity.
right. For humans, that might be, I don't know, height, maybe education level. For the common tern, this really long-lived monogamous seabird, we already know they do this.
We do. We know they show positive assortative mating for things that really matter, for raising chicks.
Like bill size, age.
And crucially, their arrival date back at the breeding colony. If you're a really experienced, high-quality tern, you get back to the colony early in the spring.
And you pair up with another early bird.
That's it. It's a great mechanism for making sure you've got strong genes and a good co-parent.
But this deep dive, it takes us thousands of miles away from the nest. We're looking at tracking and mating data from this one specific colony in northeastern Germany, a place called Rotherwerder.
And we're using that data to test a completely different kind of compatibility.
The question is this. When a common tern chooses a partner for life, does it care if that partner has the same travel plans, the same migratory habits?
I mean, this is a huge evolutionary question. These birds spend, 9 months of the year migrating or on their wintering grounds?
A huge part of their life?
So you'd think, you would hypothesize, that birds taking the same risky route to Africa, they would preferentially pair up. Maybe they share some genetic fitness for that specific journey.
It just makes intuitive sense, doesn't it? That a shared map to your winter home would be a requirement for compatibility.
It does.
Okay, let's unpack this. Do common terns care where their partner spends the winter?
We're about to find out.
Oh.
And I'll tell you the answer in these sources. It was a huge surprise to a lot of researchers.
All right, so to really get this, you first have to appreciate the sheer scale of the common tern's commute. This is not a short hop.
No, not at all. They breed in places like Germany, and then they fly all the way down the coast of Africa.
How far south are we talking?
Sometimes as far as South Africa. It's a truly epic journey.
And it's not like they all take the same highway to get there.
Exactly. For a long time, we thought European terns mostly used one major route, the Western Atlantic Flyway. That takes them down the coast of, Spain, Western Europe, and then down the African Atlantic coast.
But that's not the whole story.
Not even close. Recent tracking has shown this whole other lesser-known highway, the Eastern African Flyway.
Okay. And who uses that one?
Birds from populations further east, so Croatia, Hungary, and this is the important part for our study, a big chunk of the birds from the German Baltic coast.
So right there at the same breeding site, you've got birds using two totally different travel plans to get to the same continent.
And once they get to Africa, they just fan out. The study identifies 3 main wintering zones.
3.
Yep. There's the northwestern African coast, basically everything north of the equator. Then there's the huge southwestern African coast, so Namibia, South Africa.
And the 3rd?
The eastern African coast, mainly around the Mozambique Channel.
That's incredible. It's like they've divided the entire continent into wintering neighborhoods.
It is. And that's exactly why this colony, Rotherwerder in Germany, was the perfect place for this research.
Because it's a mixing zone.
Precisely. If you only studied a colony where every single bird took the western route, you could never test this idea. But Rotherwerder is special. Birds breeding there use both flyways.
And they end up in all 3 of those wintering spots.
All 3. So it's a perfect natural experiment. You've got 2 travel strategies, 3 final destinations, all coming back to one single spot to find a mate.
If compatibility based on your travel itinerary exists at all, you should be able to see it right there.
Right. So to actually run this experiment, the researchers used some pretty amazing tech. Light-level geolocators.
I've heard of these. They're tiny.
Tiny. Less than a gram. They're these little archival tags that just log the intensity of the ambient light.
And how do you get a map from light intensity?
It's really clever. By knowing the exact time of sunrise and sunset and how long the day is, you can estimate the bird's latitude and longitude each day.
So it's not like real-time GPS, but you get the full itinerary.
You get the whole story. So over 4 years, they tracked 120 of these breeding terns, got the devices back, and ended up with 69 complete, usable migratory tracks.
And the population breakdown from those tracks, was it what they expected?
It was. The vast majority, just over 81%, took that classic western route. But a really significant group, almost 1 in 5 birds, used the eastern route.
So that gives you the baseline. That tells you what random pairing should look like.
It does. And here it is. This is the core finding of this entire deep dive.
Okay.
When they compare the actual pairings they saw in the nests with what you'd expect from just random chance,
See, found.
no significant difference at all.
Wait, hold on. You have to stop me there. That completely flies in the face of the assortative mating idea.
It does.
You're saying statistically it looked exactly like the birds were choosing their mates blindfolded, with zero preference for their partner's travel plans.
That's probably the best way to put it. The data showed complete and utter randomness when it came to their long-distance migration.
It didn't matter if you were an Eastern traveler or a Western traveler.
Didn't matter one bit. Your chances of pairing up with someone from your own route were just.
Yeah.
Based on how common that route was in the whole population, nothing more.
Wow. And the specific examples must really highlight this.
Oh, they do. They had 36 pairs where they knew the full itinerary for both birds. And of those, 13 were mixed pairs. One bird went west, its partner went east.
They even found one pair that just perfectly sums this up, right?
They did. One of the birds took the classic western route, wintered way down in southwestern Africa,
Yeah.
Namibia, maybe South Africa,
For a standard trip,
and its mate.
its mate not only took a different route, but ended up in a completely different ocean. It flew all the way around Cape Agulhas, the southern tip of Africa,
Oh, wait.
and spent the entire winter on the southeastern coast in the Mozambique Channel.
I mean, that's the bird equivalent of one partner commuting from Los Angeles and the other from Miami, but you both meet up for work in Chicago every day.
It's an incredible image. The itineraries are just wildly different. They require different navigation, different strategies, and it had zero effect on their compatibility.
It just didn't matter. And get this, they even found a few birds they tracked over multiple years with different mates. And in one year, its partner might take the western route, and the next year it might have a partner that takes the eastern one.
So even the individual tern doesn't have a preference.
None that we can see. The bottom line is, for the common tern, where you spend your winter seems to be totally irrelevant when it comes to choosing a lifelong partner.
Okay, so that finding, it's definitive. Random pairing. But to really understand why this is such a shock, we have to look at other birds where the route does matter.
Exactly. Because in a lot of other migratory species, think European blackcaps or Swainson's thrushes, researchers do see assortative mating based on migration.
And the reason is almost always the same thing.
It's timing. It all comes down to timing.
Let's break that down. Different migration routes, they have different risks, different lengths.
Right. Different stopover points for refueling. And if you pick a tougher, less optimal route, you might just get back to the breeding grounds a little bit later than everyone else.
And if you're an early arrival, you get first pick of the other early arrivals.
That's it. And those other early arrivals just happen to be the ones with the most successful, and often the same, migratory route. So the choice isn't about the route itself, it's about the result of the route.
Which is the arrival date.
Precisely. It creates this unintentional but very measurable pattern.
And we already said common terns do mate assortatively by arrival date. The older, better birds get there first. So the logical next step for this study was to see if the route affected the arrival time.
Of course, the hypothesis was simple. Maybe the western route is just faster or easier, and those birds get back first and they pair up together.
But the data just completely overturned that idea.
Completely. They looked at the spring arrival dates. The mean arrival date for the western route birds was April 22nd.
Okay, April 22nd. And for the birds that took the much different eastern route,
April 23rd.
just one day.
One single day. Statistically, there was absolutely no significant difference between the two flyways, and they didn't find any timing differences between birds wintering in the 3 different African spots either.
Okay, you have to just think about that for a second. These birds are flying thousands of miles. Different winds, different dangers, different distances.
Depending on whether they went east or west or wintered north or south.
And yet they all managed to time their return to the German coast with almost perfect precision.
It's remarkable, and the conclusion is so powerful because it takes out the main mechanism that would cause this kind of mating pattern.
Because if everyone arrives at the party at the same time,
then everyone gets to choose from the same pool of potential mates. The biological pressure that would force them to pair up based on migration, it's just gone.
Their travel plans are irrelevant because all roads somehow lead back to the colony at the exact same time.
Which brings us to a much deeper, I think more fascinating question about evolution.
Not just
If the route doesn't influence who you mate with, and you can successfully raise chicks with a partner who has a completely different mental map of the world, how is that crucial navigational knowledge passed down? Is it in their genes, or is it something they learn?
Okay, this gives us a great point of contrast, right? You can look at short-lived songbirds, like the blackcap.
Exactly. With a bird like the blackcap, migration is it's largely genetically hardwired. The young bird flies alone at night, and its internal compass just tells it where to go and for how long.
And we know this from crossbreeding experiments.
We do. If you breed two blackcaps with different migratory directions, their hybrid offspring try to fly an intermediate route. Often it's a non-viable, disastrous route.
But the sources here argue really strongly that this simple genetic inheritance just doesn't work for the common tern.
It can't. Think about it. The Rutherfurder terns have two very clear successful routes, west or east.
Yeah.
If a western and an eastern bird pair up and their offspring inherited an intermediate genetic direction,
They'd fly straight south from Germany.
right over the Alps, and then right over the massive foodless expanse of the Sahara Desert, it would be a catastrophe.
And we know from things like ring recovery data that they don't do that. It's not a viable strategy.
So the chick has to inherit a fully formed functional map, not some messy genetic compromise.
So if it's not strongly genetic, the only other option is that it's taught. It's social learning.
Exactly. And this is something you see a lot in long-lived species, where parents have the time and opportunity to really invest in teaching their young.
And this is where the different roles of the mom and dad tern come into play.
It is. If you track a tern family in the fall, you see a really interesting pattern. The female, the mother, she tends to start her migration south a bit earlier.
And she leaves the kids with dad.
She does. The male provides the vast majority of the care after the chicks can fly. He's still feeding them, guiding them, sometimes for thousands of miles away from the colony before they finally go their separate ways.
This is a pattern in other birds too, right?
It is. You see it in Caspian terns, in oyster catchers. And it points very strongly to one conclusion. The migratory route, that map to Africa, is likely passed from the father to the offspring.
He teaches them the way on their very first trip south.
Here's where it gets really interesting, you see. This whole system, this phenomenon of the female leaving early and the male providing this long, drawn-out paternal care, it might actually be an evolutionary solution.
The solution to what?
To the problem of passing on complex knowledge that can't be hardwired into genes because of that disastrous hybrid route we talked about. It ensures the next generation gets a good, working map through direct teaching from dad.
And the fact that their mate choice is random just reinforces this. It shows the knowledge is taught so well and so robustly that the species can afford to have this flexibility. It doesn't need to put up reproductive walls between the different travel groups.
That's the idea. The social learning is what allows the diversity of strategies to exist side by side.
So let's wrap this up. What's the big takeaway here?
I mean, the central discovery is that for the common tern, where you spend the winter, how you get there, it just doesn't factor into mate choice.
And that's because all those different routes, no matter how divergent, they all lead to this perfectly synchronized arrival back at the breeding colony in the spring.
And that synchronization just prefers. It removes the selective pressure that forces other birds to mate with partners who share their travel plans.
And that, in turn, really supports the idea that these complex migratory habits aren't genetic, but are maintained through social learning, specifically paternal guidance.
The dad teaches the kids the route.
Now, the researchers do say that the smoking gun for this would be tracking a whole family, right? Both parents and the young birds, to prove the dad is the guide.
They do, and that's incredibly hard to do. Juvenile mortality is really high, and the technology just isn't quite there yet. But they say this colony, Weatherworder, is the perfect place for future genetic studies.
So what's the final thought here? The thing for you to chew on?
Well, it's this. If this highly adaptable migration is socially taught, how fast could this population change its strategy? What if one of those wintering grounds, say the Mozambique Channel, suddenly became unusable because of climate change?
They could, in theory, pivot much faster than a species locked into a genetic map.
Exactly. The ability to adapt the map through teaching, rather than slow genetic evolution, could be an incredible evolutionary lifeline for these birds.
So the next time you see a common tern, remember that its choice of mate is all about compatibility at home, right now. But its long-term survival hinges on these complex navigation lessons learned from Dad, thousands of miles away on its very first flight south.
A pretty incredible story.
That's a wrap on this deep dive.